Hello, welcome back to compiler hacking. In the last video, we worked on a smart pointer, which we called value putter, and it doesn't really do a whole lot. It just wraps a value star and makes that a pretty consistent interface. And what I did off camera was I added send. What send does is on every value star we have a send, which all method calls are routed through the send member function here, where we pass in the environment, the name of the method that's being called, and any arguments. And if there's a block, a Ruby block being passed in, then that goes here. And so what I did is I renamed these with an underscore, and then I changed all the code to route the sends through the value putter. So anytime I had a value putter thing like so, I did where I was doing thing arrow send and then the arguments. Now we're doing thing dot send, which means the calls are being routed through here. And if I show you the value putter CPP file, then all that is doing is just passing it right on through to the underlying pointer. But by the end of this video, we're going to be changing this a little bit so that we can optimize method calls on integers so that they don't have to heap allocate the integer object itself. And I'll show you how we're going to do that. But first, I wrote a little test program here, a micro benchmark. Lies. Benchmarks are lies, I know, but this will give us something to at least work towards. We have 5 integers here, and they're all going to be heap allocated. And I think that we can see that here in our profiler. We have integer value constructor being called 800,000 times, and it's 74% of the time of the program. I think, if I'm reading that right. I'm not great with profilers, but it's way up here. We'll say that. And actually, I think if I switch this to, self, I can now see it a different way. Even though it's 1% self, if I look at the very top one, which is some garbage collection stuff, and I go down the callers list, it'll be in here, I believe, somewhere. Hopefully I'm not just missing it. It's right here, and I think it's saying that that's 87% of the callers into the garbage collector is the constructor for integer value, and it's called 1.6 million times, which is insane. So like I said, I'm not great with profilers, but I know anything at the top is taking up more time, and I am a little bit unsure about this include stuff, which I assume this is 100%. Anyway, yeah. All cards on the table, I'm not an expert at this stuff, but that's what we're going to be working on. We're going to try to get this to run a little bit faster. Right now, I can shut that down. Right now, it takes right at 0.65, something like that, seconds to run that little script. And so if we can get this number to go down, I will be happy. Okay, so first thing we want to do is build another constructor for value putter, and we're going to have to pass in the global environment. And that's something I don't want to get into why. It's just part of the implementation of the runtime. We have to have a reference to the environment or the global environment. And we'll say this is integer, and we're going to set m global env like so. My fingers aren't quite warmed up today, so now we definitely need to implement that. Global env m global env, and then we need an integer at int tm integer. We'll just say it's 0 by default. And then we don't know what that type is, so I'll just bring that in. Types. And we need a way to know what type of pointer this is. If it's a real pointer and it has a value, or if it's an integer. So let's make a new type. We'll call it type, m type, type. Its default type is pointer, and we'll go implement that up here. Enum class type is either an integer or a pointer, like so. And here I need to set the m type to type integer. And for convenience, I'm going to make another one of these that just takes an environment. You'll see why later, hopefully. I don't think I can do that here, though. I think I just need to put this in the CPP file, because I don't have, I can't include env here because env includes value putter. So it's just kind of like a circular thing, but we can move it over here, and I can put it here. Value putter. Oh, what have I done? What have I done? Okay, so we're setting the type, global environment, and the integer, and then we're doing it here as well. So that looks good. Now we need a way to convert a I don't know what it's called, but a smart pointer that doesn't actually have a raw pointer value inside of it, an m value. If there's no m value, then we need to create one on the fly. And it's, I guess it's sort of like a dehydrated value putter. And so why don't we call that hydrate for lack of a better name. And we'll go over here and we'll create void value putter hydrate. And what that's going to do is I'm going to say if the m type, if it's type, wait, why are you complaining? Oh, that's fine. If it's a type integer, oh, no parens, then we're going to change the type to a pointer. And we're going to say that the value is a new integer value. So we're going to heap allocate it on the fly and pass in the global env and the integer like so. And we might as well set the integer back to 0 just to make it a little bit easier to debug later. And then we're done with that. So now let's do case. If it's a pointer, then we just do nothing because it's already a pointer. I don't have a constructor for that yet, but we can go create that really quick. Your value should be, there we go. So I need to copy this. Global, and global. There, that'll fix that. And so you should be happy now. Yep. And when are we going to hydrate? We're going to hydrate in a lot of places. Anytime we need to reference the underlying value, then I think we need to hydrate. We need to make sure that we have a real pointer to reference. Like so. If I save, it should reformat. Perfect. And the only one that's a special case where we don't need to hydrate would be these operator nots. I think we can short circuit this. We can say, so just from my brain, this is like a if not thing, and this one's a if thing. So I'll do the positive first. I don't need this double bang. I'm going to say if m type is type integer or there's a pointer, then it's a true. And this one's a if m type is type pointer and there's no value, then it's not, it's a false. I think that's right. Okay. And then on our send calls, do we need to call hydrate here? We're already calling value. which does the hydrate for us, so we should be good there. And I think that's it. So now we just need to put this to use. So we have a way of our smart pointer has a way to store a raw integer that's not heap allocated, and we just need a way to create this. So in our compiler, somewhere we are doing integer value, would be right here. So we're not going to do a new, we're going to take off the new operator, value putter, and we're going to pass in, this is a little bit gross, but this is kind of an experiment anyway, so I'll just do it like that, and then pass in the literal value. So that's how we're going to create an integer, and this will just be on the stack. There's not going to be, because I took off the new operator, so this will just be on the stack until something happens to it. So like in our code, it would be, we have a value putter thing, right? And so like it might, well, I'll just do it like that. And if we say thing.send, it doesn't, well, it does hydrate it immediately. It turns it into, internally it's going to do new integer value, like so. But we're going to short circuit that a little bit later. Let's just make sure this didn't break anything. Everything should continue to work, I think. Unless I missed something. But let's run our test suite. And we'll just find out if I broke anything. Okay, tests are all passing. This is great. So let's do something here where we just do a printf hydrate to see, just out of curiosity, how many times are we hydrating a smart pointer, a sort of shallow one, into a full pointer, a full object, that is. Let's do this. We'll call it nums2, nums.rb, nums2. Yeah, a lot. Grep hydrate 500,000 times. Oh, wonderful. So what would be really cool is right here, if we could intercept the send method call and do something different. So we say if type is integer, then I want to create a synthesized how do you spell that? Synthesize? Yeah. Integer value, m global integer, and then return synthesize dot underscore send. Pass it on through env name arg count args block. And yeah, let's just see if that changes anything. What's happening? Lost my cursor. Not sure what happened here. Is it frozen? Okay, that was weird. Not sure what that was all about. Let's just see if there's any fewer hydrates. So we're down to 300,000, so it definitely helped a lot. But let's go look at the code. Ben Natalie nums.rb, and then we'll do a debug. And let's just see what the code looks like here. So we have a value pointer here that's like the number 100 and the number 200, and then we call plus, the plus method on the first one. So let's go look to see what's happening in integer value cpp add, just right here. What's happening here is every time we use this arrow operator to reference it like a pointer, we're hydrating this value. And so what I'd like to do is create an optimized version of this function just for integers that avoids hydrating that smart pointer into a full pointer, into a full object on the heap. So I think I just need to call dot on these things. So like if it's a float, then you can do that. Assert type we'll do this way. We'll create a method for that, to nat int t, and then we'll change this to a value putter. Yeah, something like that. And we'll do it for subtract too, since we're doing a little bit of subtraction. That value putter. So now we just need to implement these methods on the smart pointer. So value putter HPP. Let's do it over here. Value putter HPP. And we need bool is float, and we need void. Actually, let's just go copy that from here, like so. Assert type. I can't reference value because it's not a known type yet, and I can't include value because value, it's a circular reference. So I need to make a new value type, and we'll come back to that in a minute. And then the last one we need is nat int t2, nat int t, like so. So these are the methods we need to implement. CPP. And we'll do that right here. Bool value putter is float. We'll say if m type is integer, then we're going to return false. Otherwise, we're going to return value is float and go and pass it on through. And then similarly for assert type, we're going to do void value putter assert type env value type const char type name. I'm going to say, so if we're an integer and the type we want is a value type integer, then we're just return. Otherwise, we're going to do value assert type env type name, like so. Now I just need to go implement this value type. So let's go to value HPP, and it's right up here, this enum class. I'm going to pull this out to its own file. Edits, include Natalie value type header. Paste this here. Name space Natalie. Let's dedent that, and let's do pragma once. And we're going to call this a value type, something like that. And then up here, we're going to say using type is value type. And I need to include it. So hopefully that makes that all happy. What are you unhappy about? Yeah, that should go away shortly. This should be happy now if I include value type. I wonder if I should just put it in forward. Nah, I'll just leave it like that. So that makes that one happy. Value putter CPP. That's happy. Okay, we did it. Cool. So let's run make, and we'll recompile our nums2 file. Didn't like that, did it? Undefined reference to nat int t. Did I forget one? I did. Nat int t value putter to nat int t. I'm going to say we're going to do a copy of this and just going to return integer. Otherwise, we're going to return value as integer to nat int t, like so. There we go. Okay, so grep hydrate. Let's see how many. Oh, we're down to 100,000. Cool. Yeah. Why would we still be at 100,000? Let's go look at our nums RB. So that means every time through this loop, one of these numbers is getting hydrated. It must be this last one. Yeah, because there's a return value from the block, and I'm guessing that that is 138. That's perfect. So yeah, I'll have to look into that later, but for now this is fine. I think this is kind of doing what we want, and this is just an experiment to see if we can speed things up. So let's get rid of the hydrate printf here, and let's do. I'm just going to run clean test to make sure I didn't break anything. Because the reason I think I might have broken something is right here. This is a big assumption that I can create an integer value on the stack and then use it in a method call in Ruby and that be okay. I think this is going to be a problem. And I think I'm going to have to add an extra conditional to this. I can probably prove that a better way. Let's see, what could we do? Let's do wat.rb. If I say one, what's a method? Tap. Okay, let's do this. So tap is a method in Ruby that passes the self, the one in this case, into a block. So if I say at I is nil, and then I say at I is I, and I try to print at I, let's open a new tab. Bin Natalie wat.rb. What happens here? Ah, we got a crash. So I don't think all method calls are safe. Segmentation faults. So this is kind of interesting. This object is like relative to our hash map member. I've never seen that before. I guess because this is a stack pointer, and it's probably being overwritten by something else. I'm pretty sure that's what's happening. So if I go look at what line number was that? 208. Print m included modules. Yeah, the size of the included modules vector is an insane number. If I look at this, yeah, this is just crazy garbage data, I think. So this type is a huge number. So this is definitely a stack pointer that got overwritten with other data. So I think I've already proved, and I've got failing tests here. So I've already proved that we can't do it that way, but I think we can do something for now. What can I do? integer value HPP. What if I create a little static, this is going to be kind of gross, but I'm going to say static bool optimized method, and we accept a symbol value method name here. Can I just do this all in line? I'm going to say return, let's say const char name is method name cster, and yeah, I can't do that in line, that's okay. We'll move this over to integer value CPP. I'll just put it down here. Integer value colon. Don't need the static. I'm going to say return. This is going to be so gross. strcmp name plus equals 0 or strcmp name minus equals 0. Then those are the methods, those are the only ones that we've optimized. And then later on we'll have multiply and divide and some other ones. But let's say and integer value optimized method. Do I already have? Yeah, I have name here. So let's do that. Let's run make. Get to make everything again. So the reason I don't know if I really explained that, but in my wat.rb example, the reason this broke is because this tap method, which is a part of Ruby built in, it passes the self object of 1 into a block, and then what I'm taking that object and I'm storing it in an instance variable outside of the block. And what my synthesize code is doing is like create synthesized value here, and then when it gets down to here, you know, it goes away because it's on the stack. And that stack frame is either overwritten or it's not relevant anymore. And so by copying a pointer to this object to a variable outside, you're going to have a bad time. So we can only do it for certain methods where we know that the pointer to the self is not going to be sent out of it. And that, oh God, I just thought of another thing. So in, I'll leave this here. Let's do wat2.rb. In Ruby, you can do class integer def plus other, and you could just say, I want to return 3. And you can run Ruby wat2, oh, gotta do something with it. Print 3 plus, let's say 10 plus 10. If I run that, I'm gonna get 3. And I hate this about Ruby. Like, why do we allow this in Ruby? I'm sure there's some, I mean, Ruby lets you shoot your foot off. That's just what it is. I wonder if I should just disallow this because, does that even work in Natalie? In Natalie wat2? Well, it won't work now for sure. Yeah, it does work. Fascinating. Yeah, that will break. I wonder if I should just disallow this, but I'm not going to worry about it right now. Integer value CPP. I'm not going to worry about it right now. I'm just going to pretend everything is happy and clouds and rainbows, and that we can always assume that plus is going to go to add, and the subtract is always going to go to sub. And then later on, I'll probably just disallow changing it, or I could have like some sort of global flag that marks like, if you want to do that, then you lose this optimization. And this would just always return false. If you do something like this, then we could detect that and neuter this whole thing and make all methods not optimized. That might be the better. That way I'm still compatible with Ruby. for, whatever reason. I'll have to think about that. But anyway, so I think we're all built here, and I did make a change, but I didn't mean to. Let's do the wat.rb. And Natalie, wat2.rb. That's the one that broke earlier, right? So that one should, not wat2, just wat. That one should be okay. Shouldn't crash. Okay, it doesn't crash. Good. And then, are we good? Are we good? Run the test suite again. Let's just do test. Make sure that our test suite all passes now. Because earlier we were getting some failures. No, actually I don't know where it was. But yeah, I remember seeing, it was right here. So we got a failure here, and I'm sure it was because we were assuming that all methods are safe. And so by adding this check to only allow certain methods to be optimized, then we're good. I don't love all the string comparisons here. There's probably a better way. Probably like I could intern the symbols for certain methods like plus and minus and multiply and divide and all that, and put it and then compare the pointers rather than doing string comparison. But this is fine for now. We're just sort of experimenting. Sweet, test pass. Test suite is all passing and didn't break anything, so that's pretty cool. Let's try our nums RB in a profiler and with time and see what happens. Nums2, nums.rb. And we can do time nums and time nums2. Oh, look at that. It is faster. It's close to double the speed. Or half the time. Yeah, look at that. Oh, that's so cool. It's not just a fluke. I can do it over and over again. Oh, let's run it with the profiler. Val grind, tool, call grind, nums2. Come on. Okay, so should have a couple call grind things here. We'll do k cache grind, call grind, and this is the old one. Come on. And then I do k cache grind, and the new one should be able to compare. Can I put this over there? And this one over here, which one's old? So this is the old one, this is the new one. Nums and nums2. And we'll just sort by, what are we sorted by here? Integer value, integer value. 200,000 times we're calling the constructor for integer value, but it's only 37% of the runtime, if I'm reading that right. Versus this one's 74% of the runtime. And the other way we were looking at it was, if we look at percentage of self, we see the garbage collector is a huge piece of that. And then if we look at the callers for the garbage collector, integer value is, wait, now I'm confusing myself. Hold on, let me go back to this way. This is the old. Yeah, it's only 37% versus, no, I'm looking at the wrong one. Okay, this is the old. 74% versus 18%? No, it's this one here, 37. Okay, yeah, that's right. Sorry, I got a little confused myself. It's all good. Okay, so let's look at callers of the garbage collector stuff, and integer value is in here somewhere. Where was it? It's right here. 87% versus over here. It should be lower, I think. Integer value 59%. Yeah, definitely. I mean, you can see it's called 1.6 million times here and only 400,000 times here, which is really fantastic. Fan-freaking-tastic. Okay. Well, I don't know. This seems like a success. The only thing I'm not super proud of is this optimized method stuff. I might think of a better way to do this, but even with these string comparisons, it was still a lot faster. And I think even if we add a few more for multiply and divide and so forth, I still think it'll be a lot faster. Well, let's commit it. And let's do add include lib and source. And let's do a commit. I just want to look through and make sure this all made sense. I didn't have anything that I was going to come back and look at again. Okay, not too bad. So optimize integer math of plus and minus by not creating, not heap allocating an object. We'll be adding more optimized. We'll be, optimizing more methods, more integer methods soon, but this is a fantastic start. And cuts runtime of a small script in half. And we'll just put the script right here. It was nums.rb. We'll just put it right here. And we'll say before and after, and we'll just do read, execute, time, nums. Let's see. Nums. Put that right there and indent that, and then we'll do read bang time nums2, and yeah, something like that. Boo 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 boo. Before, after. Let's just take off the 2. Yeah. Nums.rb. Yeah. Oh. So cool. So I'll just do some cleaning up here, and what was the last? Yeah. Oh, it's so beautiful. GPA. Well, that's it, I guess, for the whole video. You, I don't know. Let me know what you think. I think it makes the code a little more complicated, and I'm not too thrilled about that. I do like just passing around regular old pointers to everything, but it does help our Ruby implementation to be a little bit faster. And I'm afraid to even show this, but we're still not as close. Oh, I removed it. Goodness gracious. Why did I do that? Nums.rb, paste this in. time Ruby nums RB. So running it through actual Ruby interpreter it's running in 0.2, and ours was like 0.3.5. So we got a ways to go. The next thing I want to optimize is method lookup, which we do in hash map, and I think there are some ways to optimize that. Yeah, so I want to look into that pretty soon, and I think that we could close the gap here of getting our Ruby implementation as fast, or hopefully faster than MRI Ruby. But yeah, until then, thanks for hanging out, and I hope you learned something. If you see something, if you had ideas or saw me doing something stupid, please let me know in a comment below. I love to get feedback, and yeah, appreciate you. Talk to you next time. Bye.